Prashant Subramanian, and we already gave the overview of the presentation. And in the next phase, me, Daniel Gora, is going to talk about the first part. And we'd like to mention first that we have focused on the programming intensive task. And so we would like to give you an introduction into our topic. So the threat landscape of web security attacks has changed over the last years, and we identified by doing our research that there's a lot of pattern change within the recent years. So we decided to ask our questions in terms of our research, how those cyber attack patterns have changed during the course of the last decades, as the attacks of web security breaches and web security is increasing significantly in the last years. So we applied as part of our research text mining techniques in order to identify the patterns of word use within attack incident descriptions of web security databases. So our hypothetical statements, according to our research, focused on those statements, which are first attackers are apparently organized in criminal groups instead of single attackers, and they use sophisticated attack techniques, especially targeting websites and information on those websites. And there's also the second statement that hacker groups target website vulnerability in order to get unauthorized access for stealing valuable information, such as credit card data or sensitive customer data. So what kind of data set have we chosen? We chose the data set by the Web Hacking Incident Database, which is a database maintained by the Web Application Security Consortium, and it basically includes all major attacks of the security incidents from 2000. And as you can see, in each row represents one incident, and we focused on the incident description column and then the date occurred column. And the goal of this data set is to raise awareness of web application security and to provide information for statistical analysis, for example, by our research. And the data set is available in a CSV format from the OWASP website. So this is basically our data that we have focused on. It has like at least several thousand rows and a lot of text included in each incident description. So we use text mining in R in order to carry out our research, and we chose R over other data mining tools because it includes a specific library for text mining, which is the so-called TM library. And R for itself is a language that is mostly used in data mining for statistical computing and graphics, and it's kind of the most used language at the moment for data mining and analysis. And a big advantage of R is that it's fairly quick and easy to install and also to compile, and you see your results immediately on the screen. And as I mentioned, we have chosen R because the the packages in R are very useful for our research. For example, we chose random forest for carrying out random forest, TM for text mining, and the core plot library in order to visualize correlation plots. So the methodology used as part of our research was the KDD, the knowledge discovery process. And we, in fact, ran through every phase of this methodology, which we're going to talk about each step in the next following minutes. So, which are the selection phase, the pre-processing phase, transformation phase, data mining phase, and then also the interpretation and evaluation in order to get knowledge. And we use several algorithms, which are the frequent term analysis, association and correlation, k-means and hierarchical clustering, as well as random forest decision trees. So the first step of the KDD process is the data extraction cleaning phase. So the first thing that we did, we imported the data set into the R language. And we extracted and imported the incident description and the date occurred columns from the data set into R. In the next step, we applied data cleaning techniques by removing all the white spaces with a certain function, changing all words to lower cases, reducing all words to its root form using a certain function called stem document, And then we removed all stop words, which are, for example, words like off, from, the, from our text mining, from our text matrix. And then we removed all punctuation and numbers. And additionally, we applied further manual cleaning on that data by removing data errors and omlauts. And we were not able, however, to reduce the code contained in the incident description, but we're going to talk about this later on. So the next phase is the data transformation phase, where we pre-processed the data and transformed it into a document term matrix. So a document term matrix can be seen on this picture here, and it's basically a matrix that describes the frequency of words that occur in a collection of documents. So for our example, each incident is one row in our document term matrix, and every word contained inside this document is a column. So this is our, for example, you can see the word ABC, for example, is 0 times contained in the incident description of number 1. The next step is the frequent term analysis. So as part of the frequent term analysis, we used the terms of the incident description column, and we identified what kind of terms are occurring mostly. So we identified that the word attack, group, and hack are occurring over 100 times. And then we also did analysis of frequent terms that occurred less than 100 times, and we found very interesting patterns. For example, that the word SQL, the name injection, the word exploit, and the word DDoS have occurred inside the incident description column multiple times, which indicate that um, those web security breaches are exploited fairly often within the recent years. The next step is the word association analysis, where we try to identify terms that highly relate to each other. So we have chosen the word attacker, hacker, information, and group because those are the most frequent occurring words from the previous analysis, and they also contribute heavily to our hypothetical statements that we have made. So we found out, for example, for the word attack, the word website and web was highly related, as well as for the word group, the word hack and website was highly related. And also for the word hacker, the word access and use was highly related, which indicate that hackers use means of access in order to steal information. So in the next phase, we did word associations over time by including an additional column from the web hacking incident database into the document term matrix. So we repeated the step data extraction and cleaning again and added this to our document term matrix. And the next step, we also aggregated those the date into years in order to have a useful overview of chosen words per year. So what you can see, for example, is that the word group has occurred since 2006 only twice, and after that it increased significantly into 32 times, 43 times, and 82 times, which indicates that group attacks have occurred since 2006 quite often compared to the past, where there has been no group attack at all. And this gives us a good overview over the change of attack patterns and over time. So in the next step, Prashant is going to talk about data correlation of annual work trends. Thank you very much.